Good morning, All-Stars. It's day 3 on the specialist schedule again, and today we're going to have a look at simulations. Now, a simulation is a way of using technology to try something that might be too dangerous or expensive or repetitive to do in real life. Some examples might be, if somebody wants to learn how to fly a helicopter, it would be far safer for them to practice in a simulation before doing it for real. Or maybe an engineer wants to find out how much weight a bridge will hold. It wouldn't make a lot of sense to build the bridge and then stack weight on it until it broke. Or maybe if you wanted to see what the inside of the sun looked like, a simulation would be a much cooler way to do that. So today we're going to have a look at this website where you're going to have the opportunity to learn about some math and science concepts and practice what a simulation is. The website address I'm going to put in the description below, so whenever you are looking to get here, that's where you'll go first. And it's going to take you to this page, which is going to let you know that this is from the University of Colorado at Boulder. As we scroll down the page to the bottom, you'll see some of the sponsors that they have used to help build this page, and this kind of helps me to know that this is a very reputable, respectable, and trustworthy site for me to be able to use. Well, I'm going to point at simulations right now so that I can choose by grade level. You'll see up here that we have a bunch of different categories, but I'm going to pick grade level because the website itself has elementary, middle, high school, university, college level kinds of simulations. And it's probably better off to start at elementary. Now, if you've done a number of elementary simulations and you'd like to look at something a little bit more complicated, you can easily do that by clicking over here on the side. Now I'm going to look at two specific simulations today, show you how they work, and then give you the opportunity to maybe have a look at them too, or try something else different for yourself. Now the first one is my area builder. And if you're familiar with math, you know that area is something that we can do to figure out how much space is inside something. But we're also going to compare it with perimeter, which is how much space is around something. And this is a great simulation to let me see how things can change. Every one of the simulations gives you a chance to kind of learn and explore, and then a chance with the game. I'm going to start off with the Explorer today because it's going to give us all the things we need to know. When we look at our simulation screen, you're going to see my graph paper in the middle. I have a counter at the top that's going to calculate my area and perimeter for me. And I have some different tools at the bottom. This we'll look at in a minute. These are my squares I'm going to use to build my area models. And over here is another tool that I'm going to show you in just a moment. So let's start off. We'll put a couple of squares on my screen, 1 and 2. So you'll see that it's counted for me at the top. My area is 2. That's just counting the number of squares. My perimeter is counting the number of sides around my shape. Now I'm going to go back to this to show you what I mean. The check marks will turn on and off my graph, but it will also turn on and off my numbers. It will keep track of the numbers on each side. So here I've got 2, 4, 5, 6, just like they've done. So they kind of do a lot of the work for me. And if I wanted to cheat a little bit, I could always turn this off and I could turn that off as well. But what I would like to really do today is have a look at this other control at the bottom. And this is going to split my screen so that I can see two different models at the same time. And what I'm going to do is I'm going to make two models with an area of 5. That means that I have 5 squares. 1, 2, 3, 4, and 5. And I'm going to do the same thing with my purple. 1, 2, 3, 4, 5. Now, they both have an area of 5. They both have a perimeter of 12, and we'll check that with our numbers. 5, 5, right? 1 and 1 is 12. But they're in a little bit of a different direction. Same shape, different direction. But what happens when I start moving some of the squares? Well, Still have an area of 5, still have a perimeter of 12. What if I move this guy? Okay, area of 5, perimeter of 12. Let's try this one. I still have the same number of squares, but my perimeter's changed. Um, this is an excellent way for you to be able to explore and experiment with area and perimeter and see how the area of a shape will rarely change, but the perimeter can. Okay, the only way that I can change the area is to remove one of my squares. Every time I do this, no matter what, it's still going to have the same number of squares as long as I don't take one out or add one in. So, great tool for learning about area and perimeter. Now we're going to go back. I'm going to look at my next one. This is a science simulation. Now I'll wait for the computer to catch up. And I'm going to scroll down because I need to show you something important. We're going to do the energy skate park, and you can see it says the basics. This is the same simulation, but this is a Java simulation which can be downloaded to your computer. Works just the same as doing it online. I prefer to do it online. It just saves me from downloading to the computer. But you would be free if you'd like to scroll through and download any of the other simulations that are better played on your computer. Um, Anytime you see this number 5 symbol, that stands for HTML5, which means that it's going to run on any computer, tablet, or phone. And it's going to work the same all the way across. The Java and the Flash games are ones that may be a little bit more tricky to play on your computer, and you might need an add-in. But on to our simulation. So, Energy Skate Park is going to talk about the science concept of energy. And there are 3 different kinds of energy that we'll be looking at and learning. At this point, it's not super important that you understand all of the terminology and what they mean because we're going to kind of figure it out as we go through. So my game is going to load up, and we're just going to start right now with the intro. But you'll notice here that I've got a friction game and a playground game. Start with our intro. I can still see my other 2 down here so I can move whenever I'd like. The introduction is really to show you what the screen is going to look like. I have my skater, I have my shape, and over here I have some different things that I can turn on. The pie chart, the bar graph, the grid, and the speed. Now, I'm not going to worry about the speed or the grid right now. I'll leave that up there. Now, I'm going to take my skater and I'm going to put my skater on my U shape. And when I let go, the skater is going to go all the way down, hit the bottom, go all the way up the other side. And what we're watching here on the side is the total amount of energy. The potential energy is the energy that she gets at the top. That means that she hasn't gone anywhere yet. It's kind of like winding up a toy or a spring. There's no energy coming out of it until you let it go. So you can see that the kinetic energy is what energy is being created as she moves. Now, the nifty thing to understand is the total amount of energy is not changing. The potential energy and the kinetic energy are. And if you were able to look at this on a bar graph, you would see that the energy, the green plus the blue, always equals this kind of orangey shape. This is going to be important as we look at some of the different parts of the other game. You'll notice that the red line, or the thermal energy, is not going up at all. And the reason for that is we don't have any friction. Now, friction we're going to look at in the next game. And friction is simply the heat that is made when 2 things rub together. Just like when you rub your hands like this and the hands get hot, friction also slows things down. So let's turn back on our pie chart and on our bar graph, just like we did with the other. But this time I have another control for friction. We are going to leave that, let's start off with none, just like the other one. And we'll change it as we go. So put our skater back on, and down goes the skater. And again, we'll see my kinetic and my potential going up and down. But as I start to add friction, watch what's happening. My red thermal energy line is starting to move up as well. And as more energy is being created by the friction, then my skater is going not quite as high each time. If I add even more, she's going to come to almost a complete stop. All right, so let's put us back in the middle. So as I change different parts of my simulation, I'm able to see what happens. Now the playground section is kind of my favorite part because I get to build my own shape. And I do that, you can see my screen is pretty much the same as before, but now I've got an extra tool at the bottom, and it's got these three circles. You pick it up and drag it on my screen, and I can use the circles to make shapes. And I can add more to it to create my own, almost kind of a roller coaster shape, I guess. Now, I played with this for quite a while, and what I tried to do was create as many different shapes as I possibly could, where the skateboarder was able to go all the way through the roller coaster shape, all the way up to the other side and all the way back down. So let's do this, and we'll just add one more, and I keep adding as long as I want. All right, so let's try this and see what happens. And again, we're just going to leave the controls the same. Let's see what happens with our skateboarder. She goes down, and she goes back up. What do you think is going to happen? Is she going to get all the way over? No, not quite. Now, I may have to do some changing, but you'll see that when she starts going back, hmm, let's see if I drop my friction, because remember, friction is going to slow things down. And let's take our skater again, put her back up, and when I drop my friction, let's see if she goes all the way up to the other side. Well, that helps a little bit, but she still didn't get all the way to the top. So this was actually probably one of my favorites. I played with this for quite a while and tested different shapes and different sizes. Um, it's nice to put in the pie chart and the bar graph because it helps you to see what's happening with the energy as she goes along. Well, I hope you enjoyed this today as much as I did. And I hope you've got an opportunity to take some time to practice, have a look at some of the other simulations, and make sure you're keeping track in your journal of all the things that you're doing. Pretty soon, I'm going to be asking you to start creating a collage on a special website for me that will talk about all of the things that you did while you were in quarantine and away from school. Well, looking forward to seeing everybody back at school sooner rather than later, I hope. And I hope you have a great Ask You Day and see everybody soon. Bye.